Hello there, and welcome to YouTube Space Lab Live. I'm Bill Nye, the science guy, broadcasting live from right here on Earth in the Google Creator Space in London to space lovers all over the globe. Now, over the next 40 Earth minutes, we'll be creating our own chaos theory here in the studio, and helping me are a bunch of very special hangout guests and bona fide space geeks whom we'll meet a little bit later. Plus, the piece de resistance of this space-tastic show will be linking up live with the International Station, which is 250 miles away. That way, hurtling through space and talking to a live astronaut, Sunita Williams. So if you have any questions you've ever wanted to ask a real live astronaut, you can send them in to us via Twitter, Facebook, or Google Plus right now. But why exactly are we all here? Well, last year, YouTube and those clever folks at NASA came together to launch an amazing competition which gave you guys the chance to get all creative and dream up an experiment to be conducted by NASA astronauts on the International Space Station. But what I want to know is, how do you come up with these far-out ideas? Well, I'm joined by Space Lab creator Zahan Bahamel to tell us a little bit more. So, what is Space Lab?
YouTube Space Lab is a global competition where we asked students around the world to come up with an idea for an experiment that could be carried out in space. Professor Stephen Hawking, one of my childhood heroes, and other brilliant minds picked the best, and here we are today in the world's largest, coolest scientific classroom to see the two winning experiments in action.
And this was your idea?
It was.
So, how did you come up with this?
I think that Space Lab was born out of a desire to inspire the next generation. When I was the same age as our Space Lab winners, space inspired me. And so my hope is that Space Lab will inspire the next generation, and that today's Space Lab winners could be tomorrow's space explorers.
The people who one day walk on Mars are maybe kids right now.
Absolutely,
right?
absolutely.
It's pretty great. Well, thank you very much.
Thank you.
So let's head into my laboratory, okay? Hey, you guys, follow me. Now, the Space Lab story began about a year ago. And armed with only a whiteboard, a camera, and a selection of colored markers, thousands of young science enthusiasts set out to create experiments fit for NASA's finest. But unfortunately, only 2 experiments could win the ultimate prize.
My name is Dorothy Chen. I'm 16 years old.
I'm Sarah Ma. I'm 16 years old, from Troy High School, Troy, Michigan.
Hello, my name is Amr. I am 18 years old. I come from Alexandria, Egypt, and I'm currently in a gap year.
We got the inspiration for our experiment from previous research on Salmonella. A strain of this bacterium was grown in space. When it was brought back down to Earth, it proved to be more virulent than the original strain. In our research, we found that phosphate ions prevented the increased virulence of Salmonella. So we wondered if the same inhibitor could curb B. subtilis' effectiveness. We are planning to send the QST-713 strain of Bacillus subtilis into space to see if it will become more virulent to fungi like Salmonella was to mice.
My experiment is designed to investigate the effect of microgravity on the way the jumping spider, specifically the zebra spider Salticus sinicus, catches its prey. Will the Salticus sinicus be able to catch its prey in microgravity? I don't think so.
And here they are, our worthy winners. Amr Mohammed from Alexandria, Egypt, and Dorothy Chen and Sarah Ma from Michigan in the USA. Guys, first and foremost, congratulations. This is fantastic. These entry videos must seem like a long time ago now.
Yes.
Now, Amr, let's boldly discuss where a few men, women, a dog, a monkey, and now, thanks to you, some jumping spiders have gone before. Outer space. What is it about space that grabs you?
Well, I like space because unlike any other science, everywhere you look in space, there is a new mystery, a new unknown, a new interesting question to inspire one to look for an answer. In any other science, you have to go further than that, very deep into the science to come up with a really inspiring question.
That's cool. That's great. Dorothy, Sarah, how does it feel to know an experiment that you thought up is being carried out by NASA astronauts on the International Space Station in space.
It's definitely really surreal to think that our idea, you know, the one that we were brainstorming so many months ago, is actually being conducted on the ISS.
It's your thing.
Yeah.
It's cool. Look at you. It's great, you guys.
We're
This is great. Yeah, it's very nice. We're going to see the results in just a few minutes. So, Amr, this isn't the extent of your prize. I mean, there's more to it. You also went to Russia, didn't you? And you experienced the training needed to become a fully qualified cosmonaut. So let's see how you did.
I've always been fascinated by science because with a handful of equations I can explain the world around me. The idea of sending an experiment to space is the most exciting thing that I have ever heard in my life. I'm very grateful to be here in Star City and try all the cosmonaut activities. It has been amazing to experience the G-force of the insertion and of the landing. Also, I'm really looking forward to the space flights. I was very surprised by the amount of equipment that the astronauts have to study before wearing the spacesuit in simulated zero gravity. It's harder than it seems. It has been amazing to try the spacesuit and come here to Star City and try all the cosmonaut activities. It definitely has changed me.
Not bad. Did that give you a taste for becoming a cosmonaut?
It has been fascinating, and now I have to become a cosmonaut, I think.
We're all looking forward. Wave to us when you get up there.
All right.
So, Dorothy, Sarah, you guys headed over to Japan, right, to watch your rocket go with your experiment. I guess you had to trust them to get it right.
Yeah, we knew what they would get.
Yeah.
So let's take a look.
What I'm most looking forward to during my visit to Japan is probably the rocket launch. I mean, I think that's something that normal people just don't get to see. That's not something you get to witness.
This is the closest that we're ever going to be able to go and see a rocket launch, and I've always wanted to see one ever since I was a little kid.
I think it's very exciting that our experiment is currently on board. It was a very exciting moment to see like the rocket with our project in it and like just finally launch it.
You could feel the vibrations and you could see the fire and the smoke, and it was just it was great. Dreams really do come true. Our experiment is actually going into space, and we were just brainstorming it in a little classroom in Troy, Michigan, and now it's actually going on the ISS.
Wow, you guys, that just looked amazing. That was cool. How did you feel knowing your thing's launched up in space?
It was an incredible feeling. I mean, there's a lot of pride in it, a lot of like gratefulness. There's a lot of grateful, like, wow, like I'm so glad that we got this opportunity.
Yeah, so thrilling, definitely.
And so we're going to see the results in just a few minutes. Somebody's going to report to us from orbit, for crying out loud. So now, as I mentioned before, we are being joined by some VIPs from the Space Lab community via our Google Hangouts. So joining me are Space Lab judge and educator Becky Parker.
Hi.
Greetings. European Space Agency astronaut and former space commander of the International Space Station, Frank de Win. Okay. You're with us?
Hello.
You're with us? Greetings.
Yeah, absolutely, I'm with you. Absolutely.
Good. And then we have an eminent scientist who studies spiders, Peter Smithers from Plymouth University.
Hi there.
Mm-hmm. And from BioServe, Stephanie Countryman. There you are. Greetings.
Hi.
So thank you all for hanging out with us on the Hangout. Becky, I'd like to start with you. You're a teacher. How important is it to try to engage kids with science and especially the space industry?
Well, the study of space is so mind-blowingly fantastic, and studying the universe, that you want to study it anyway. But it's really essential that we get young people interested in science and able to solve some of the big problems like energy production and food. And so we actually need them to be scientists studying problems here down on Earth as well.
Exactly. Fantastic. Peter, I want to bring you in here. Do you think science can make the advancements needed without space exploration?
It can make some advances, you're absolutely right, but it's a bit like trying to understand our entire planet. Like taking a stroll around your garden. We need to get out into space if we're going to fully understand the mysteries and the wonders of the universe.
Fabulous. Now, Frank, you're a former commander of the space station. Why is it so important to you? Why is it vital that we explore space?
Well, it's very vital. If you look in the past, any time that societies have progressed, it's because they started to exploring. It's because they gained new knowledge, new experiences. So we have so many problems here on Earth. And if we want to solve those problems and really advance humanity, we need to continue to explore. And of course, the next frontier is space. So space is one of the areas in which we absolutely need to go further and to explore.
Fabulous. You've crystallized my thoughts. Stephanie, can you remember what turned you on, why you got excited about science and space?
Yes, I've been fascinated by science since I was a little kid. I can remember as far back as then being interested particularly in nature and the living organisms and trying to understand how they work. And since I started working for BioSurf 13 years ago, being able to look at living organisms in space has just been a unique opportunity that is, I hope a lot of other people get to have.
It changes you. It's fantastic. So listen, I've been the CEO, the executive director of the Planetary Society for a couple years now. I've been a member for 32 years. So I am very excited about what's going on today. Guys, we're going to have to leave it here because I'm getting word that we will be checking in with the ISS in just a few moments. It's just over the Atlantic right now. So for you International Space Station fact-finding buffs, I want to remind you it's going 28,000 kilometers an hour. That's 470 kilometers a minute, 8 kilometers a second. That's like 17,500 miles an hour. It's 10 times faster than a bullet. So I hope our satellites can keep up. No, I'm kidding. They're actually going a little bit faster. So now we're going to link up with the ISS and our astronaut, Sunita Williams, in just about 10 minutes. So I thought we should look at our winning experiments, which are currently hurtling through space. Can you bring over your jumping spider experiment there off the shelf? What exactly were you trying to find out with your spider cage in space?
So I was trying to find out the effects of microgravity will have on the jumping spiders when they hunt their prey. I chose this habitat because it had a chamber where the spider can stay until the box make it to the International Space Station. The chamber supports the spider and
has water and
provides everything that the spider needs to thrive. It has another chamber for the fruit flies, which I chosen as prey. And once in space and ready to begin, the astronaut uses the plunger system to release the fruit flies into the main chamber, and the experiment can begin.
So let's take a look at your eight-legged friend here. This is the zebra zebra because it's got the happy stripes on its.
It's the Salticus sinicus, the zebra spider. It has 4 pairs of large eyes, curved legs, 8 curved legs, and spinneratus
for making silk. Spinneratus
to glue silk threads.
So these eyes, this is a special deal for them. Whoa, whoa, it's a lot of eyes.
So the 4 pairs of eyes provide the spider with a very wide view, and it's actually wider than the human eyes.
Yeah.
And so wherever the prey is, it's always on the spider's radar screen, and the spider can locate the prey. And its eyes are actually almost as good as human eyes.
And they see in color.
Yep.
Wow. So here's the representation. The spider is eyeing its prey, hapless fruit fly, and the plan is, I guess, the spider's going to jump like this, right?
Oh, here on Earth, the spider can can estimate the distance and can adjust the trajectory to compensate for gravity and land precisely on the prey.
So what's this right here?
So before it jumps, the spider glues a silk thread to the surface that's jumping from, so that if it misses the target, it can climb up the thread and try again.
Yeah, it's one thing on a flat surface, but if it's jumping like from a plant or
From a flower example, it
So,
can really save its life.
So here we have a representation of comparing the spider jump to the Olympic broad jumper or long jumper. And I see the spider goes, no, that's the human that goes 8 meters, 0.31, 8 meters. And so that was this year's gold medal, and that is about sort of 4 human body lengths, but this jumping spider goes a lot farther than that in body lengths, right?
So in terms of body length, the spider can do a lot more than 4 body lengths in its jump using no special muscles.
And no running start.
It doesn't have to.
So the idea is that you predicted the spider would have to make some adaptations in space, right?
So in order to survive, it has to adapt, because I suggest for the first 3 trials, the spider would just
Go
try
straight.
to...
Yeah.
It will compensate for gravity as it does here on Earth, so it will miss the target and just continue going.
The target shown here.
Yeah.
But you think that after a while, maybe we'll see if the spider can adapt, right?
So at sometimes I thought they might die, but I really hope they adapt.
We'll see.
Okay.
But look, you guys, come on, spiders on a space station. The screenplay is going to write itself. Woo! So you're saying this is an exact replica of the spider cage?
That one in space.
Spider habitat?
Yeah.
Everything's fine, but you know, there's no spider in there.
Oh, there's not? Where are they?
Did you guys see that? Did you see that? One small step for one giant leap for jumping spider kind. That's really good. Thanks, man. That's great. Thank you, Mom. All right, let's move on to the other experiment. Dorothy, Sarah, your experiment was inspired by previous work that was carried out by NASA on the International Space Station on the most stomach-churning of bacteria, Salmonella, right? Ooh, gives me the creeps. So astronauts find that these bacteria that had been in orbit and came back to Earth were somehow more sick-making, more, what scientists call more virulent than they had been before they left. So, Sarah, Dorothy, how did you come up with this? What was the idea? What grabs you about this?
Well, what we wanted to find out was, because the salmonella becomes bad, more and more bad in space, more virulent, we thought, if that could happen, why not make the good bacteria more good and more virulent, but in a way that would be beneficial to humans? So these 2 bacteria both have a common gene called the HFQ gene, which makes
our good friend, the HFQ.
It's a good friend, yeah.
Hey, can you get the gizmo off the shelf there, would you, Sarah? Yeah. So this is somehow you got the bacteria packed in these fabulous space-worthy tubes, right?
Right. We put them in the top, and then Sunita Williams, astronaut, she cranks it, and then once they're in space, that lowers the bacteria into the bottom chamber where we have different mediums for them to grow in.
Yeah.
And so you don't want them mixing before you leave. That would sort of mess up the experiment.
No, we don't want to, it's going to be purely growth in space.
So this is what Bacillus subtilis looks like. I think, correct me if I'm wrong, the real ones aren't quite this big. Right?
Not quite, no.
So I would think maybe that if they, bacteria just divide themselves in half, they'd split down here like when you barbecue a hot dog. But these go like this, right? They split this way. They remind me very much of Cheetos. And we're in Britain, I got to tell you, they don't call them Cheetos, they call them What's-Its. So then you would say, what's it? And I say, yes. Yeah, would you like it? Oh.
Not a fan.
Yeah. I've never, that I know of, tried Bacillus subtilis, but this probably tastes better. So the idea is these things multiply really fast, right? They're bacteria. So once they're in space, they're dividing and dividing. First you get 2, then you get 4, then 8, 16, 32, 64. No, you get a lot of them. Yeah. So somehow you're thinking that they'll reproduce better. They'll get more fit, be stronger, more excited, Bacillus subtilis.
Yeah.
So they'd multiply like this, very fast, many of them.
Right.
But the idea was something can hold them back, right? So you came up with a set of test tubes, if you will.
Yeah, so for the control, we were thinking like that would be the normal growth for Bacillus.
Yeah. This would look like on Earth?
Yes, and then like unaltered, which would be the same test tube,
as the control, only it'd be in space.
This one here. So
Yes.
this represented, this would be just a few little
Yeah.
bacteria here, many bacteria.
Yes.
And then so these things, you mixed some stuff in with them, right?
Yeah, we thought since like a phosphate ion was thought to have curbed the growth and the virulence of the Salmonella bacteria.
Oh, on another experiment.
Yeah, on the previous experiment, we thought that maybe if it's the same gene, maybe the phosphate will help curb the growth and the virulence of the B. subtilis that we had.
So Dorothy, what's going on that one?
So we're thinking that the fertilizer it has phosphate ions because that's what fertilizer is mainly made of, but it also has other impurities, other chemicals that are added to do what
That might be
fertilizer
similar,
does.
like nitrates, phosphates.
Right.
Yeah.
Yeah.
And so we're thinking that those might also interfere and curb its growth even more.
So you guys, in just a few minutes, we'll see what happened. Very cool.
Yeah.
This is very cool. So let's get back to the hangout. Frank, if the hypothesis is correct, does this mean that the results of these experiments will make it easier for astronauts to be in space longer and go farther and deeper than ever before?
Well, we hope so. At least it's one of the things that we, of course, working on. Today we are flying around the Earth, but of course we want to go further. We want to really explore, go back to the Moon, go to Mars. Who knows where we will end up? But there are a lot of questions that we will need to answer to do that. But the interesting part is, of course, that if we can answer all those questions, all these scientific things, that this will not only bring benefits to astronauts flying further to the Moon, to Mars, but it will also bring a lot of benefits to the people on Earth. And this is really the interesting part of everything that is linked to space exploration.
Well, interesting. You've been in space, right? What's it like?
Oh, it's great to be in space. First of all, you can float, and much like the spiders in the beginning, of course, you have to adapt, because if you aim for something, you normally miss it in the beginning. And our human brain can adapt. It will be interesting to see if the spiders can adapt.
How long, when you were in space and you tried to hand something to somebody, how long did it take you to figure it out?
Well, a couple of times, not so much, because our human brain is, of course, very evolved, and we are very adaptable species. So it would be interesting to see how a spider brain or reflexes would adapt to that. But the other interesting part that I wanted to say in being in space is exactly observing our Earth from above. Because when you're there, you really realize that actually I was an astronaut, I was in space, in a spaceship. But we are all astronauts on spaceship Earth. This is really important. We are just a very tiny ball in this immense universe.
I know, it's amazing. It's overwhelming, and you've been there. I'm sorry, Frank, we got to keep moving, because I've just gotten word that we're going to talk to your colleagues up on the International Space Station very, very soon. Thank you so much, sir. Carry on. You guys, it's not bad. Let's go to the other side of the lab, to the laboratory den. We'll go through the secret door. Well, it's not secret. I mean, it's right here. Hey, this isn't bad, huh? So right away, Becky, you were one of the judges. What was it about the winners that made them stand out?
Well, three things really. If you think they've really exploited in an original way the opportunities for being in microgravity. There's a lot of really rigorous science there. They've shown some really good scientific method. And also, they're just so enthusiastic. They're going to be brilliant scientists for the future. So they stood out as fantastic entries.
So, Stephanie, these are young people and so on, but are these experiments worthy of space? I mean, are they just as good as other experiments on the International Space Station?
Yes, they're very similar to the types of life science experiments that we do up on the space station. And they all had a scientific basis for being conducted in a microgravity environment. So they're very typical and very worthy of being conducted in space.
That's great. Yeah, you guys, we've got to leave it right there, because I can see that the International Space Station is just crossing the orbit of our communications satellite. And although I am not an astronaut, I applied, but I can say at least we have a laptop that's just as cool as the one that they have. So let's go over to NASA Mission Control and link up with the space station. So you guys look at these people. They're at mission control, and I presume they are doing what? Controlling the mission. So they're thinking deep. So look at them. They're sitting there nonchalantly. The thing's going 28,000. It's going 10 kilometers a second. Oh yeah, whatever. 8 kilometers a second. 10 times as fast as a bullet, and we're just yeah. And so
Houston on
I think we got it right here. Houston, it's Bill in London. Can you hear us?
Houston, station on 2. We're ready for the event.
YouTube Space Lab, this is Houston. Please call station for a voice check.
So, station, can you read us? This is Bill Nye at YouTube headquarters in London. Do you hear us?
Sonny, we got you loud and here on the International Space Station. How you doing, Bill Nye, the Science Guy?
We're fabulous. You're looking great. It's very exciting. So can you just reassure us, that you really are in the space station? You're not suspended by hidden wires in a closet someplace. Maybe your hair alone kind of gives it away. Yeah, it's pretty good. It's pretty good.
There would be a lot of wires holding my hair up right now if that was what it takes. But I guarantee we're up in space. I don't think I'm not a gymnast, so in normal life, I don't think I could do this.
Wow, very nice, very nice. And you were able to do it in slow motion.
I can do it as a 10.
Very nice. Well, we really appreciate you taking time. Very nice. She stuck the landing. Very, very nice for taking time out of your schedule. You got a lot going on up there. I'd like to introduce you to a few people we have here back on Earth. We have the winners of the YouTube Space Lab competition. We have Dorothy and Sarah and Amr. Greetings, everybody. Greetings. Now, Sonny, you've been working on their experiments, right?
I'm excited to be here with you guys. I was happy to have met you guys in Washington, D.C., and congratulations. I think it's been a little bit of a whirlwind for you since that time, so I hope you're enjoying yourself, and we're enjoying your experiments up here, so thank you.
So you look very relaxed, and you set your microphone down. That's very nice. Or set your microphone up, or where is up. But what is a day like? I get the impression you guys are busy all the time.
Well, every day is different, and we are busy all the time. We have a general working day, same time as you, GMT. But we usually get up around 6 and try to go to sleep around 10. But every day is different. We're doing science experiments. We're exercising. We're out doing spacewalks. We're doing robotic stuff. We just launched HTV, the Japanese module that was up here, left us yesterday. So it's one thing after another. Every day is a little bit different. It's awesome.
Spacewalks, launching Japanese modules, making scientific discoveries, that's routine. But you have any other stuff you have to do, like the laundry and dishes and things like that?
Well, luckily enough, most of our food is in containers, and then we throw it away, so we don't really have dishes up here. If you think about it, dishes aren't going to work up in space, so we just sort of eat our food out of different types of containers, so we don't have to do that.
What sort of food do you eat?
There's not a lot of dirt up here, so your clothes don't get dirty for the most part.
What sort of food do you get to eat up there? That delay is from the speed of light.
We have a wide variety of food, which is really great. Just in this in this little packet, I have beef fajitas, which we usually eat with tortillas because bread is a little crummy and then it makes a mess and gets in your hair and stuff. A lot of freeze-dried stuff, or dehydrated stuff, I should say. And we have a hydrator right above me. This is cauliflower and also spinach in here because my mom's probably watching and wants to know I'm eating my vegetables. And then, of course, there's things in a can. And, of course, we have candy and other things like that, which are, everybody likes to eat on Earth.
It does look like, it does look delicious. But how about the experiments? Can you show us the experiments? Oh,
Certainly. I think you're thinking about experiments that these guys sent up, right? Am's experiments and Dorothy and Sarah's experiments. And they're right here with me. So I have them here in space. This is a gap. This is Dorothy and Sarah's. And it shows a little bit change of color from when you remember it launched. It was before a little bit more red, and then we combined them in the gap experiment. And so now, obviously, with the dye, they've changed, which means there's definitely some indication of some growth. But we'll have to see how that goes when they get returned to Earth on SpaceX coming up at the end of October.
So this is where there's a dye that changes with the acidity, and so as the bacteria metabolize, as they metabolize, it changes color. Yeah. So do you guys have a question for her right now?
Exactly. And the other experiment, which I think... the other experiment, which I think you guys want to take a look at, if we can get the camera to focus, is, of course, our little Nefertiti here. Let's see if she can get in focus. Hold on.
She's she's in focus, yeah. I see a lot of dead flies.
Well, she's a little scary.
All right.
I think she's been eating well.
So, do you have a question about your spider here?
Yeah, I'll shoot a question. So I see there are a lot of dead flies hanging around in the silk threads. Did you get to see her actually do the jump?
Oh yeah, she was in the CGBA. I'm sorry, the in her habitat there, and then also in the locker where the payload folks were able to see her with the camera, and that's what this is contained right here. But every now and then, of course, I took her and Cleopatra out and fed them, by opening the plungers and opening so more fruit flies would come out. And one day I was doing that. I had the light on like this because, as you know, they hunt in the daytime, and I wanted to take a look and see if I could see her. And my gosh, I saw her stalking a fruit fly, unbeknownst to that poor little fruit fly. And she was looking at it, and she was going real close, and all of a sudden she jumped right on her. So it was amazing. And so I think the spiders absolutely adapted to space. It was incredible to watch.
Wow, I'm watching you. You're very impressed. That's very cool. So the spider's able to adapt just as you predicted on. So Sarah, Dorothy, do you have a question for Sunny?
Yeah. Hi, Sunny.
Hi.
So we were wondering, can you see any differences in how yellow each test tube is to show the levels perhaps that our bacteria has grown depending on the medium it's in?
I'm sorry, can you repeat your question one more time?
Oh, are there different
levels of yellow? Can you see the different color changes, or are they all the same color?
No, they're all different. Actually, this one I just randomly picked number 5. But they all have a slightly different color. This one is really nice and orange, but some are a lighter color and some are a darker color of red. So yeah, they all have a little bit different. So I was wondering about all the data points that you guys picked, because I was wondering why they were all the different colors. And I noticed it pretty much the first time I took them out and looked at them when I was taking the pictures, that they were definitely different ones, had different colors. So you're going to see some interesting results when you get these back. And right now we're keeping them at 4 degrees in this chamber, so it should maintain its, where it is until it gets back on the Earth for you.
That sounds great.
So that's what you guys predicted, yeah?
Yeah. Yes.
That's not bad, people.
Yeah.
Look at you. Both of you, both experiments came out pretty much the way you predicted. And Sunny, you are an extraordinary part of this, and we very much appreciate it.
Thank you.
Yeah, thank you so much.
So it's not just that these guys here have been hoping to ask you questions, and thank you for answering, but we have some questions from their classmates in Michigan in the United States. Here we go.
Hey, Dorothy and Sarah, and everyone in the studio. We're back here in Troy, Michigan, and we also have a question for Sunny the astronaut.
Obviously, the Olympics were this summer, but we were wondering how international relations changed after we found out who got the gold medals.
Very interesting question. We actually, we have a little bit delayed TV up here. If we get streaming video, it's called KU. And so during the Olympics, we would get KU and get all of the highlights of the Olympics at dinner time, which was great. As a group, we would gather around the table and watch the Olympics. And I thought it was more of a bonding experience between all of us as we were cheering for each other's teams. Like when Japan would win and when Russia would win, we'd all be like psyched for each other. And I think that's really good for international relations. It was not, on anything bad. It was more like we were supporting each other and, and got to know each other's athletes through the knowledge of the other crewmate on board. So it was really fun.
That's very good news, because our next question comes from an Olympic gold medalist. The guy who, competing with spiders, was the long jumper who won, Greg Rutherford. Greg.
Hi, Sunny. Greg Rutherford here. Just wanted to ask you a quick question. If Aunt Spider was my size, she could outjump me on Earth, but could she outjump me in space?
We've cut to Stephanie.
I think
That's
just
all
by
good. Here
mass, I think you could probably outjump the spider.
No, good. Well, that's good. It's good to know. Our next question comes from the flight director of the Mars Curiosity rover mission, Babak Ferdowsi, the Mohawk Man. Babak.
Here at the Jet Propulsion Lab, we work on robotic missions. What we'd like to know is, how could we further improve robotic missions to help human exploration?
That's a really great question, because some people sometimes think that robotics and human spaceflight are a little bit, back and forth. There's some type of competition there. But I think robotics are awesome because they'll take the first step where we haven't had the technology developed quite yet for humans to go. And then the second thing they can do, once humans get there, they can take on repetitive tasks and do repetitive tasks such that the humans can take then the next step in exploration. So I think robotics and humans can step by step and leapfrog each other so we get further and further and understand more about our universe. So I think robotics and human spaceflight together are an awesome combination.
That's fantastic. As the CEO of the Planetary Society, this is something we advocate. I'm delighted you feel that way, Sonny. It's great. Let's change the world. So this is good, but we've got tons of questions from our live stream viewers from all over the world. So we're going to start with Pekka Ulala. What is the most beautiful thing you've seen in space? What is the biggest insight you've had, Sonny?
Well, I tell you what really is humbling is when you look out the window and you see something like the aurora borealis, or the lights in the southern hemisphere. Also, it's just amazing because it really puts us in our place. That we're, the energy around us and in the universe is overwhelming and more than we can even imagine with our minds. And there's more and more for us to discover out there. And then, of course, looking at our planet, it's just pretty. I mean, it's blue, it's green, it's purple. The clouds are forming, the ice is forming. It is just spectacular. And I've said it a number of times. I wish everybody would be able to take a lap around the planet, and then they'd have a much better appreciation for it and the people who live there. And it's just so peaceful and pretty.
Oh, that's great. You are our ambassador. You are our woman in space. Thank you. We have another question. This one from Caden Kuchera. Does it ever bother you to be in such a small area, in such a confined space up there?
Oh gosh, no. This place is great, and I was here when it was a little bit small and we only had 3 people, and now we have 6. but we have, over 10 modules, and, it goes different directions from the front of the spacecraft all the way back to the, the Russian segment back there. It's like a 5-story house. There's windows to look out of. Everything in space is more fun. Cleaning is fun. So you don't get tired of being inside because there's always a lot of things to do. And every now and then you get to go outside too. So that's a lot of fun as well. So no, I never get tired of being inside here. It's great.
That's cool. We have another question from Brianna Page Henderson. About how long is your training? How long did you work to get ready for this? And what are some of the things you had to do to prepare?
That's a great question. I think people don't realize that the space station, like I said, is big, and there are a lot of things. We don't have electricians and plumbers and computer, IT folks up here. We do it all ourselves, and so the training is about 2.5 years, and it consists of learning about the U.S. segment modules, the Japanese, the European, the Russian. So that means a lot of travel around the world. Learning the Russian language also because we fly up in a Russian Soyuz vehicle. We learn about how that spacecraft works. And so the training is pretty extensive on skills-based, so we can be able to do all that plumbing, electrical stuff, water stuff, science stuff. So it's a lot of skills-based, but it's about 2.5 years, and it's a lot of fun. That's when you get to know your crew because we all train together.
Now, speaking of getting to know your crew, I think none of us could miss. Somebody went flying over your right shoulder. Who was that?
So that was Aki. Of course, he represents the Japanese Space Agency here. Him and myself and Yuri Malenchenko from the Russian Space Agency flew up on a Soyuz. But also who's up here on a different Soyuz getting ready to go home on Sunday is Joe Akaba, another American, and then 2 Russians, Gennady Padalka, Sergei Revin. So we've got a sundry of people, and in another month or so, another Soyuz will come up with another American and 2 Russians. So it's pretty busy up here with spacecraft coming and going and people flying in, flying out. This is a laboratory. We're working here, so you're going to see people moving around.
But they move around in extraordinary ways. I mean, they're all flying. It's pretty cool. So we have another question from our social media. This is from Douglas Martin. What does Sirius look like when you're up there, when you're closer to the star? Sirius is a star. Or what does any other star look like, really?
So it's an interesting question, and we're only about 250 miles, 400 kilometers above the Earth. So when you're thinking relatively, that's not very far from the surface of the Earth when you're thinking about how far other planets are and stars are. So size is about the same as you would see from Earth. However, without any atmosphere, the universe is crystal clear. You can really see the 3D of the darkness that's going out there. I mean, it doesn't look like a black sheet. It's like it just goes on and on. Likewise, stars are crystal clear and they're bright. And so you see definitely different sizes, just like you do on Earth, of stars, that some are smaller and some are bigger. But they are just crystal clear, and at night it's like millions and millions of stars. It's in some place you've been where there's no light pollution and it's just a crystal clear day. It's beautiful.
That's just cool. So you guys, do you have any other questions? You got it right here, right there.
I have a question. How many sunrises do you see in a day, in a 24-hour?
So in 24 hours, we go around the Earth 16 times, so you'll see 16 sunrises and sunsets. Here in the laboratory, we've got a window below us, but it's taking some really nice pictures, and so we have it covered up with a black cover, so the pictures will come out real well. The cupola is around the corner, and sometimes it's right where the gym is, and so when you're lifting and working out, you can see the sunrise and sunset right above you. But I tell you, when we were on a spacewalk, you can really tell the difference. The heat, just the heating and cooling from the time when the sun is up and when the time that it's dark is unbelievable. Before the sun even shines on you, you can feel the heat start to generate around your body. So it's impressive, the vacuum of space, how much heating and cooling goes on out there and how much sun changes things.
That's fantastic. And I remind you, it's not magic. It's science. That's pretty cool, Sonny. Thank you so much. I'm afraid we're about to lose you. Our satellites are going to lose touch with you. But do you have any final words for the winners, for Dorothy, Sarah, and Amr? Thank you so much.
Well, of course, congratulations to you guys. Your experiments were awesome up here. I know that there were thousands of other wonderful participants in this contest, or this, I think, more of a gathering of scientific minds of our future. So thanks to everybody who participated. You guys all made the contest awesome. We're just honored to have been part of it. So thank you.
Thank you, Sonny. That's just great. Thank you so much. We'll let you get back to work. Oh, wow. That was just wonderful, wasn't it? She's flying in space, you guys. Come on. Thanks, Mission Control. Thank you very much. We'll let you get back to work as well. I mean, how cool was that? No, it's routine. God, wow, amazing. I've tried that, but it's much harder for me. So that was, I don't know about you guys, that was my first live link up with an astronaut. You guys, that's your day at the office, is it? Yeah. That was pretty good.
Yeah.
So how do you feel? Your experiments are flying.
It's weird. It's like we saw the prototype for our bacteria container, and now it's like she's holding it, and it's just really surreal.
To see it work
yeah.
is mind-blowing.
Yeah, it's mind-blowing.
It's a great honor to have. I mean, the best scientists and astronauts are the ones who work in the International Space Station, and it's an honor to have my own experiment be done there.
So, that's you guys. That leads me to something. Stephanie, if you're there, how much work goes into this? I mean, these guys, the students, had an idea, but you got to get it up on the space station. How much work? How hard is that?
It's a very complex process to develop an experiment to be conducted on the space station, from designing the hardware to support a living organism that typically lives in an environment outside, to live in an environment as naturally as possible. Now they have to live in an unnatural environment, so designing the hardware is complicated. And then also then training the crew and meeting all the safety requirements so that the astronauts are safe when they conduct the experiment. It's quite a long and complex process, but it's also exciting.
And you pulled it off. And I could see the experiments. They're working just as you planned. It's fantastic. So going over to Peter now. Peter, are you going to pack up your day job with spiders and become an astronaut?
Well, it would be cool to be an arachnological astronaut. I must confess, that's very tempting. But I must confess, the food doesn't sound that wonderful. So I might pass this once.
Now, when you say the food, are you talking about what Sonny was eating, or what the spiders were eating? No, I didn't. I'm kidding. I'm kidding. Well, I'm sort of kidding. Becky, do you hope this will get more people involved? More people, young people especially, you want to support space exploration?
Well, I mean, how inspirational that those young people's experiments are there working brilliantly. It will surely inspire more people, and we need more opportunities for students to do experiments in space. I think that's what we need, to inspire yet more people to be scientists.
Becky, you got to pull back. You got to give us some enthusiasm. Come on. No, it's fantastic. One last, Frank, while you're there, what do you hope for next in space exploration? What do you see coming up?
Well, in space exploration, there are a couple of things that we need to do next. First of all, we need to go further away from our planet. We need to go back to the moon, to Mars. And of course, we know that this will require a lot of resources. So we need to bring everybody around the world together. We now have an international space station, but there are so many other nations still in the world that do not participate in space exploration. And we also need to integrate them. This is a big wish of our European Space Agency, to bring a lot more nations into this magnificent world of space exploration, of science, of inspiration for young people, and of bringing this planet back forward.
That's fantastic. You know, space brings out the best in us. It raises our expectations of everybody in the world. It makes humans worthy of our place in space. It's fantastic. Thank you all very much. Thank you for coming. It brings us to the end of our live stream, and there's just enough time to thank Sunny, our astronaut, NASA, Space Adventures, JAXA, the Japanese Aerospace Exploration Agency, ESA, the European Space Agency, Lenovo, and of course, all of you guys for watching and uploading your videos and ideas for the competition. Space Lab does not end today. Oh no. With YouTube for Schools, your school can sign up to access Space Lab as well as thousands of free, high-quality educational videos on YouTube. Just follow the link on the channel for more. We want to make it the place online to keep up to date with all things scientific. So make sure you keep checking in. We're going to sign off now with our Space Lab tribute to a legend. I'm sure you're all aware, science and space exploration lost a true icon recently. I was on my knees as a 13-year-old looking at the black and white television, and now I'm the CEO of the Planetary Society. It all started with a guy who, on the 20th of July, 1969, with one small footstep for a man, changed the way we look at our place in space. It changed us. It changed ourselves forever. So thank you all very much for watching. I'm Bill Nye, and we'll see you next time on YouTube Space Lab.
It's one small step for man, one giant leap for mankind. It came in peace for all mankind.